Hi friends, today we are going to talk about the basic operating principle of an electrical transformer. The history of transformer dates back to 1830s when Michael Faraday discovered the principle of electromagnetic induction. Over the years, transformers have become more efficient, reliable and powerful. Before going to discuss transformer operation, let's find out what is meant by electromagnetic induction. Electromagnetic induction is a fundamental principle in physics and engineering. It is nothing but a process by which a changing magnetic field induces an electric current in a conductor. Have a look at this picture. As per the setup given below, Michael Faraday arranged a conducting wire attached to a device measure the voltage across the circuit. When he moved a bar magnet through the coil, the voltage detector measures the voltage in the circuit. Through his experiment, he discovered that there are certain factors that influence this voltage production. They are number of coils. The induced voltage is directly proportional to the number of turns or coils of the wire. Greater the number of turns, greater is the voltage produced. Another factor is changing magnetic field. A changing magnetic field affects the induced voltage. This can be done by either moving the magnetic field around the conductor or moving the conductor in the magnetic field. So the Faraday's law describes the relationship between changing magnetic field and induced electromotive force. The induced EMF is proportional to the rate of change of magnetic flux. The direction of the induced current is such that it opposes the change in magnetic flux that is described by Lenz's law. The mathematical equation is E is equal to N d phi by dt, where E is the induced EMF, N is the number of turns, and phi is the magnetic flux, and T is the time. Now we are going to discuss about the basic operation of a transformer. Electrical transformer, it's a static electrical machine which transfers electrical power from one circuit to another without changing the frequency. Transformer can increase or decrease the voltage with corresponding decrease or increase in the current. Have a look at this picture. The basic principle behind working of a transformer is the phenomenon of mutual induction between two windings linked by a common magnetic flux. The figure at left shows the simplest form of a transformer. Basically, a transformer consists of two inductive coils, primary winding and secondary winding. The coils are electrically separated but magnetically linked to each other. When primary winding is connected to a source of alternating voltage, alternating magnetic flux is produced around the winding. The core provides magnetic path to the flux to get linked with the secondary winding. Most of the flux gets linked with the secondary winding, which is called as useful flux or main flux. And the flux which does not link with the secondary winding is called as leakage flux. As the flux produced is alternating, that means the direction of it is continuously changing. EMF gets induced in the secondary winding according to Faraday's law of electromagnetic induction. This EMF is called mutually induced EMF, and the frequency of mutually induced EMF is same as that of the supplied EMF. If the secondary winding is a closed circuit, then mutually induced current flow through it, and hence the electrical energy transferred from one circuit, that means from primary circuit to another circuit, that is the secondary circuit. Let's see the step up and step down operation of a transformer. Step up or step down voltage according to the ratio of the primary to secondary wire turns. A transformer designed to increase the voltage from primary to secondary is called step up transformer, and a transformer designed to reduce the voltage from primary to secondary is called a step down transformer. Let's have a look at this picture. Here you can see the number of turns in the secondary winding is more than the number of turns in the primary winding. So here the voltage is step up, and the next picture, the secondary number of winding turns is less than the number of turns in the primary winding. So here the operation is step down operation. Another important factor about transformer is transformer ratios. Understanding these ratios are very important for designing and operating efficient electrical power system. Let's have a look at this picture. An ideal transformer is shown in the picture. Let's consider V1 is the primary side voltage and V2 is the secondary side voltage, and N1 is the number of turns in the primary side and N2 is the number of turns in the secondary side, and I1 is primary current and I2 is secondary current. Now, what is turns ratio? Turns ratio is the number of turns of primary winding divided by number of turns of the secondary winding. That means N1 by N2. Voltage ratio is V1 by V2. Current ratio is I1 by I2. Now let's see the relationship between these three ratios. N1 by N2 is equal to V1 by V2 and it is equal to I2 by I1. Thank you for watching this video. If you found this video helpful, be sure to like, comment and subscribe for more content.